What's going on, everyone? Steven here, back with a new video for you. This is a scenario that can be helpful for you for a number of reasons. Basically, this is dealing with multiple results from an AOB scan. All right, and so I'll show you what I'm doing with it here, but you could also use this for things like iterating through all your results from an AOB scan and addressing like one of the specific ones. Like let's say you have 15 results from a scan and you want to do something with the seventh result, right? Well, if you use just a regular autoassembler script, when it runs its AOB scan, it just immediately applies everything related to the script to the first result. So if we switch this over to Lua, which I've done here, if you switch that over to Lua, then your results are actually a part of like a string list in an array. So you can target different results. So you don't have to have a unique array of byte pattern for just one result. Okay, so this is sort of counterintuitive from what you probably normally think about, where you want to have something as unique as possible, right, to have it apply to that one thing. But this can help you like not have to try to drill down so far into getting a unique byte pattern sometimes, or like, well, let's say with emulators, for instance. Like if you typically there are byte patterns with functions in emulators that always exist at the same places in memory, but there will be multiples of them. And you can apply the same thing to multiples of them. So instead of needing to isolate one and have it be unique, right, you could either apply something to all of them, or you could choose one from the results, right? So let's say you want to have multiple results from your AOB scan and you want to target the seventh one of out of 15 or something. You could do that with this method, okay? So yeah, I'm just going to walk you through what I did for this particular game here, and then, you know, kind of reiterate what I've already covered. This is a super crazy buggy game, Bowsette. But anyway, basically, I wanted to find values related to to pitch and yaw. So camera related values, but stuff like, you know, the up and down, like pitch, and then yaw moving around. I wanted to find a way to modify those values, right? So first off, let me show you a little trick here. This is my, I already have it here. Let's do first scan. So I have array of bytes selected as the value type, and here's the array of bytes. All right, so when you run an AOB scan, whether it's in the autoassembler or like I'm doing through Lua, it's doing this exactly right here for you, right? Okay, so this is showing two results. Now, normally, if you wanted to do something with these, you would want to make this a unique array of byte scan, you know? So let's go to this one here. Let's browse this memory region. All right, let's see. Let me resize some of this stuff here. I've resized my monitor to record this so that it's larger, so it's easier to see on mobile, because more and more people are watching on mobile. So I want to make sure that you can see all this stuff. Okay, so if we go, let's see right here. So these will be float values. Display type float. All right, so here's what I did. Okay, I fired up the game. I found pitch by like moving all the way as high as I can go, right? And then moving it as low as I can go, which is about here, and then moving up, 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 and just doing scans to find the value of pitch. I found that, and it was in this address over here, which you can see changes whenever I move around, right? But you only see pitch there. You don't see like yaw. Well, if I move it completely down and then I move around there, you can see, right? So yaw moving around is somewhere else. But anyway, so I started with pitch, and then I looked at instructions that access this address, and that was a whole rabbit hole that I went down. Okay, so instead of trying to deal with the instruction and if it's a shared instruction and trying to find differentiators in registers or in memory, instead I've looked around in memory local to where this value is. Okay, and so watch this value here. Okay, this 24.60. If I move the camera all the way up, look at what it is. 75, right? So look around on the screen there, and you'll see here in memory 75 right here. All right. So if I move the camera down to here, negative 25. Where do you see that? Right here. Okay. So instead of me finding the instruction related to like removing the maximum value of pitch, so how high you can move the camera or how low you can move the camera, these look to be min and max values. So if I change this to like 10, or I'm sorry, actually we would want negative, I don't know, 85. Okay, we can keep going, right? So now we have a full min max. We didn't do anything with instructions. We found the values that the game pulls from for its min and max for pitch, right? So anyway, what I'm getting at here is that you don't have to just look in the registers related to instructions that access an address. You can look around in that memory region, find some values that look like they probably don't change on their own. Oh, let me move. These little dudes are attacking me. All right. Yeah, you can like get up here. You shouldn't be able to, but this game is like crazy buggy. Anyway, okay, so back to this. So what I did was I looked around in memory here and I found a few values that don't seem to change at all. And it's stuff that, like, let's say the programmers updated the game, right? And they changed the instruction that like writes pitch, or they changed something that even breaks an AOB scan of yours related to instructions. Well, they're probably not going to change the min and max. I mean, maybe they tweak those values, but there's some stuff that they are probably going to keep the same. When they were developing the game, early on they decided this is going to be how high and how low you can move the camera, and that's what it is. I don't know. Anyway, so what you can do now is if you want to build like an array of bytes based on those, like let's say it's these three values here, okay? What I could do is, let's see, I can go, is it copy to clipboard? That doesn't copy the address, that copies the value. Sorry, it's been a little while since I've used Cheat Engine. Let's just add the address. Okay, yeah, we'll do that. Go add address, we'll copy the address, okay? Then up here in the disassembler, we'll say go to address, and we'll paste that address in and say OK. All right. Now we know this is data, that these aren't instructions. They're being interpreted as instructions because we're up in the disassembler, but these are the same memory addresses. This one here and here. These are the bytes related to these values. So if we right-click here and we said display type as 4-byte hex. All right. So if I were to try to build an array of bytes based on these three values, all right, if I tried to scan for C1, C8, 0000, 42, 96, 0000, etc., that wouldn't work because something to do with Indianness, E-N-D, end, Indianness. All right, you can look that up and what it has to do with here. But long story short, so that you don't have to worry about moving these bytes around in a way that they'll work for an AOB scan, which here you see 0000 C8 C1, right? So we've got 0000 C8 C1. It's like it's backwards up here. You know what I mean? So that's why if you go to like add this address to the list and you copy that address and then you go to it up here, now what you can do is basically look at what you want your bytes to be. So the last byte will actually end up being 44. Okay, 44. See, 4479 4479 C000 C000 4296, which will be 429600, blah blah blah, right? So now I can just hold shift, click these, right click, and say copy to clipboard bytes only, right? And now that I have that, I can go here, paste that, right, and say new scan, first scan. All right, I have 3 results. So maybe you want to add one more in there to make it more unique, or maybe you don't care and all of these are just fine for you to change, right? So anyway, then you could copy this AOB, paste it in your script, and boom, you've got an AOB based purely on values, right? So that's pretty cool. Okay, anyway, I didn't really want to like get too far into that, but I did. So hey, there we go. All right, so back to the script now. So here's what we do. Let me do this first. I'll go back into Memory Viewer, and let's say right here we went Tools, Auto Assemble, Template, AOB Injection. And then we say OK. All right. See, the AOB scan that's generated here should be unique. That's because it's going to apply what it does here to the first result. You might have more than one AOB scan result, right? And if you do, what's going to happen as a result of this here is that it will be applied to the first of all the results, right? So instead of dealing with that, we want to be able to work with any or all of them. And I'll show you. I have another video where I've shown you how to convert an auto-assembler script to Lua. So I have it on the screen here. You can just go check it out there with the link that I have. But here in this script, so I have my scan set up. I have those bytes defined here to do an AOB scan, and the result of that will be stored in this variable, this global variable called scan, right? And then scan has a property on it called count, and that count is how many scan results were there. 0, 1, 2, 10, right? So if I do new scan, and this is the array of bytes that I have here, right? I have 2 results here. So this results total variable is going to be 2 because scan, which is this variable, right, dot count, which it knows is a property on this, is 2. Okay, and then I register a symbol for that because I'm going to be using that outside of this script. And I'll show you that in a second. Okay, so right now we want to make sure that this AOB scan is going to complete before we do what else we need to do. So a little tip for that is you can create a timer and set it for just like 1 millisecond. Timers run after everything else is basically completed, right? So this is a way for you to kind of wait for this to happen. Okay, if we had just done the for loop here outside of this function, it would like execute before this is finished, and our results total and the stuff that we want to do wouldn't be there for us to do, so we'll get errors. Okay, so we can wait for that AOB scan to finish. All this here and this is just set up for the timer. Okay, so once all this runs and the timer fires, okay, we go into a for loop here. And the way for loops work in Lua is that you define how many times you want something to run, basically, right? So here I can just say I have my initialized variable here. This is like a count. If you don't know how for loops work, imagine you want to do something 5 times, right? You want to yell 5 times. So you yell once, and then on your hand, you hold up your first finger, right? You yell again, then you hold up your second finger, right? This I is like your fist, and this number here is like your fingers. Like how many times have you done something? This number over here is, okay, after you've done something, which is inside the loop here, after you've done something, I want you to increase this number by this number, or decrease. This could be a negative if you wanted to do that for whatever, right? Okay, so this is how many times it's been done, okay? This is increase this after you've done something. This is how many total times do I want to do something, okay? So the first time that this runs, this is set to 1, right? And this is the first time it runs through. So then this will increase this. The results total here is 2 in this case. So this will be 2, all right? And this will run one more time because it's 2. So basically it runs up to and including the number. So however many times you want it to run. Whatever this is, that's what it's going to do. Unless you like increment by 2 or 4 or whatever, then this, you would have to divide. I don't want to get too confusing. But long story short, just assume that you start at 1, you increment by 1 every time you do something, and it runs this number of times. So for us, we have 2 results that'll run twice. Okay, so what happens whenever we get in here? We're going to register a symbol called camvals. ... is Lua's way of like concatenating strings. So if you want to, basically add 2 strings together. So let's say this, you want camvals1 and camvals2. Okay, camvals3, camvals4. Basically, I'm trying to register a symbol for every result. So this for loop would work, for every single result in the scan. This could be 800, right? And this would register a symbol of camvals1, and then when it ran, this would be 2, camvals2. Okay, so yeah, you've got your string here. We're concatenating I, which is here, and that's a number, so we're converting that to a string. Okay, so that would be camvals1. All right, and basically what we want to do is here we're referencing scan here. All right, I, which is here, let's say it's 1 minus 1. And the reason we're doing that is because arrays are 0 indexed. So the first result is at the 0th index. It gets kind of confusing if you're not really into programming, but basically this on the first pass, because this is 1, is the same as saying 0. So 0 is the first result of the scan, right? So I'm just doing that because we can have this automate, and whatever I is, it'll just be -1 to reference the correct result inside of scan, right? And that's what it applies the symbol to from those results. So every memory address that pops up here will now have a symbol registered to it that I can reference externally. Okay, so then I destroy the scan here, which frees up that memory. Then I destroy the timer. Boom. So basically when I enable the script, it does the AOB scan. It gives us this global variable, I register a symbol for it, of how many results there are. Then here we register symbols for every result, and that's it. That's what happens on enable. All right. On disable, we unregister all those symbols, and then we set results total to nil, and then we unregister this symbol. Now, like in the auto assembler, you can do unregister symbol and then do like a star inside of here and not have to worry about specifying exactly which symbols you want to unregister. But to do that in Lua is quite a bit more involved. So yeah, anyway, okay, so let's say we enable this, okay? I'm going to enable that, all right? And actually, before I do that, I'm going to keep that disabled, and I'm going to go View User-Defined Symbols, all right? And here's where you can see symbols that have been defined by you, the user. So whenever I enable this, let me bring that window back up there, all right? Here we have results total and camVals1, but we don't see camVals2. So if I do new scan here, boom, it looks like between the when I did the scan before and now, maybe garbage collection happened and that other result was cleaned up. So now there's only one, right? And so this is another reason that you could use something like this. Like maybe this byte array here, or this pattern of bytes, everywhere it exists in memory, at any time, you can do your changes that you want to do, and it's fine for all of them. All right? So if the game is like, I don't know, coming up with another one in memory, and you need to disable this and re-enable it, it's totally fine, right? So anyway, here's our symbols that we have, and there goes my character falling through the map there. Anyway, so now we could just double click here. Let me bring up the memory viewer and come back over to this. Okay. So boom, I've double clicked this and it takes us to camVals over here. All right, results total. All right, we don't see anything there, so instead let's go here, go to address, results total. All right, is it disabled? No, we should, oh duh, because it results total is done, I guess. Anyway, okay, let's look at this real quick. Okay, so here in this particular script, right, this is going to be making use of that results total of what's there from the parent script. So that now has 1 instead of the 2 that I usually get there, right? So now that it has that 1, what's going to happen here is I want to write a new pitch min, a new pitch max, and a new zoom in value. So you can also zoom in and out of the character, zoom out, zoom in, right? And it's going to do these changes to every single result, okay? And yeah, so it's just another for loop, same type of setup, and then I'm just going to write float to cam. All right, here I've set up a table called cam, and then inside of that table I have a base that I've called camVals, right? And then I have offsets that I've defined within that structure. Pitch min is +4, pitch max is +8, and zoom in is offset -1c. Okay, so if I found more stuff, more offsets within this camera structure, I could just continue adding them to this table. And then I just say, okay, in this table, and we're going to use, we're going to reference this particular item in there. So base, all right, this key of base, whatever its value is, which will be, this will be camVals. We concatenate to string I, so that will be camVals1, and then we will concatenate this cam offsets, so cam dot offsets, all right, and then inside of here, pitch min, which is this offset. So this would be camVals1 +4. So that's the address it will write a float to, and then that's the value that we want written there, right? So now if we come back in the game, something's changed, an offset to one of these things has changed in the game natively after an update. We can change that here. C, and then boom, anywhere that pitch min is referenced throughout here, it's changed, right? We didn't have to come back in and change this in a million different places. Okay. All right, so that's that for loop. And then if we disable the script, it just writes back the values that I have identified as the original values to each of those places, right? And then I set cam to null. All right. So if I say OK, if we go memory view here, and let me go back to view, user defined symbols, cam vals, go there. All right, so actually let's go to it here. Go to address, cam vals 1. And then we want to view this back as float. Okay, so -25, 75, and then we have this 1 here. All right, so if I enable this, and then I look back at memory viewer, this is now 0, this is -89.5, and this is 89.5. If I disable this, boom, they're back to the original values. Okay. So, yeah, let's say we had like more than one result we wanted, and instead of, you know, every single one, we wanted to apply this to like the 7th result. Then like inside this for loop, you could say if I, you know, equals 7. Like if it's the 7th result, then, you know, then you could put all this stuff in here inside this if statement, and only for the 7th result would it apply these changes to, right? So that would be like a super easy way to do that. And then one last thing here, this G sub version. This was the initial kind of version that I was trying to figure out how can I create a string dynamically using the address, the number of symbol, like if it's camvals1, camvals2, 3, 4, blah, 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 and then the offset. And initially I tried to have like, you know, this one address for the pitch min, camvals, and then covfefe, and then +4 as the offset. Well, you could do string.gsub, which you specify your variable name, right? And then the thing that you want to replace, and then what you want to replace it with, right? So basically this looks at this variable here. It looks for this text or whatever you specify, covfefe, and then it replaces that with whatever you specify here. So this would be I, but to string. So that would be like 1 or whatever. And then I have that inside of a write float, which writes the value. So that was the initial iteration, and that's just kind of like, I just wanted to show you this because it's like, you know, when you're trying to figure this stuff out and sort it out, you know, sometimes you come up with a solution and that's good enough. Good enough is good enough, right? And then maybe you want to refactor and something feels wonky and you're like, there's got to be like a better way to do this, something that can provision for more changes or something that doesn't look as goofy as having covfefe and everything. Anyway, so yeah, that's pretty much it. And now that Bowsette is all like pixelated over here, that probably marks the end of the video. All right, hope you enjoyed it. If you're new to the channel, subscribe. Give me a thumbs up if you enjoyed it. Let me know your comments in the description, and I'll just talk to you all in the next video. All right, take care.